In this video, we will show a simple Turing machine add example. We are going to be adding two numbers, 6 and 5, which are represented as 110 and 101 in binary respectively. These values are put onto a Turing tape. Additionally, the operation code 00101 is the binary value that tells the person in the box that they need to perform an addition. So how would we go about this? Well, the first step is to read the operation code until we hit a space. So we're going to get 0, 0, 1, 0, 1, and space. So we send that operation code to the control unit, which in Turing's thought experiment was the person reading the book and determining what task they need to do. Since the task is 00101, the person in the box knows they need to perform an addition. But they need to get the two values they're going to add. So the next step is to count the number of bits in the first value until they get to a space. And now we're going to count the number of bits in the second value until we get to a space. In this case, both values are going to be 4. The next step is to move back one space, and then we're going to set a carry bit equal to 0. We are then going to say, while num2 bits is greater than 0, in this case num2 bits is currently equal to 4, first thing we're going to do is we're going to store the current bit that we're pointing to, which was pointing at a 1, onto the piece of paper that the person is using as a local memory, and then erase the value from that tape. We see here that b bit is equal to 1, and this value here has now been erased. Next, what we're going to do is we're going to subtract 1 from num2 bits. It was 4, and now we only have 3 bits. Now what we're going to do is we're going to move over to this specific value here. We're going to move num1 plus 1 bits. And what we're going to do next is we are going to add the values of cn, the current value of the carry, the b bit, and the location that we are pointing to on the tape. Since this is 0, 0, and 1, the result is going to be 1. Then we put C in equal to C out. In this case, the carry bit is 0. Then what we're going to do is we're going to move back num1 bits. At this point, what we can do is we now can start the process again and keep going on a loop until num bits is equal to 0. Again, what we're going to do is we're going to set 0 equal to b bit, and we're going to erase the current value on the tape. Then what we're going to do is we're going to subtract 1 from num2 bits, and then we're going to move num1 bits plus 1, and then we're now going to add the value we're pointing to, cn equals 0, and b bit equals 0. Again, 0 plus 1 gives us the value 1. So we would erase the value on the tape and replace it. But since the value is 1, it will remain the same. We don't have any carry bit. So now what we're going to do is we move back, and then what we're going to do is we are going to make the value that we're currently pointing to 1. That's going to become b bit, and that value is now going to be erased off the tape. Then we're going to move back 5 bits, and now what we have is 1 plus the b bit, which is 1, plus cn, which is 0. So when you have 0, 1, and 1, in binary, this becomes 1, 0. What will happen now is our cn will now be equal to 1, and this value of 0 is now going to replace the value on the tape. We see that cn is now updated. So now we move 4 bits back, and we are at the last bit that we need to update for num2. We're going to set b bit equal to 0 and erase this value from the tape. From there, we are now going to move. We're going to subtract num2, we're going to be 0, then we're going to move again. Now we have 0 plus 1. This is going to give us 1. And then we're going to set carry in equal to 0. Now we get to this loop here, and now num bits 2 is equal to 0. At this point, we can now assess the value that's on the tape. In this case, it's 1011, which in binary represents 2 to the 0 plus 2 to the 1 plus 2 to the 3, which is going to be 8 plus 2 plus 1, which is equal to 11. The original problem was 6 plus 5, so now we know that we have the correct result.